We are now moving directly to the presentation number 10, Condition Monitoring and Predictive Maintenance Solutions for Intelligent Ports with Max Dietrich. So, hello Max, what are you going to show us?
Hello Ramona, thanks for the announcement. Now we want to talk about condition monitoring and predictive maintenance and what's therewith possible in the ports area. So like cost savings in the service or also reduction of downtime. And therefore we have also some success stories and examples with us.
Sounds really interesting. I'm looking forward to it. If the audience has any questions, don't forget to put them in the chat. And with this, I leave you alone. The stage is yours.
Okay, thanks. So, I want to start and want to do a focus on this very huge topic, condition monitoring and predictive maintenance. So on the slide you will see 3 photos, 3 graphics. So STS crane, ITG crane and HGV. On these applications we want to have a focus today. So you see also on these graphics some red and yellow fields. And this is area monitoring with sensors of SIG, and there we will have later on, also with our success story, a focus. What's not part of this presentation now is the topic data source, so where we get the data from. Also the topic IoT infrastructure is not part of this presentation. My colleague Lukas Kollberg will tell you something about that later in his presentation. So now we want to focus us on the health status of the devices itself and also on the task of the devices, what's there with possible. So let's start with the topic health status and what's there with possible. So there we have a focus on services, and I want to start now with a kind of maturity index of service. So you see here reactive maintenance, preventive maintenance and predictive maintenance with condition monitoring, all buzzwords. And our experience from SIG is that a lot of users are in stage 1 or stage 2. So reactive maintenance, starting with this point, like the name is saying, you act after an incident. So the main disadvantage is, of course, you have really high downtimes, but it's easy to implement. The second stage, preventive maintenance, is about service intervals, that you do services every month or every year, for example, and you have regular actions to reduce the risk of incidents. The disadvantage is there, you need a lot of resources and you have a risk, but it's a well-known approach, so you know it also from your private life. Today we want to talk about predictive maintenance with condition monitoring. So you have a proactive and forward-looking service. You act before something happens. The disadvantage is there, you need an initial effort, and the effort could be high, but it allows a lot of effectiveness and you can act need-based, and that's a really important point. Coming directly to some examples how it could work. So if we talk about condition monitoring, we talk typically about live data and historical data. If we take now some sensors like LiDAR sensors that I mentioned before, then we can monitor, for example, the overall device status, so that what you can see on the display of the sensors itself. We can also monitor the contamination, for example, also in the port area, a really important point. Because there you see, okay, how dirty is the front screen of the sensor. You see it in live, like you can see here in the picture, or on the right side, the historical ones. So there you see, for example, for a half year, that every second month there was a cleaning. And so you get a lot of knowledge about the historical data. The same also with the device temperature, also possible. So if it's too warm or too cold, it could be also interesting to monitor that you have a lot of information about the health status of the device itself. Coming to the topic predictive maintenance, also important for the health status, and therefore we need each time a lead question. If we talk again about the contamination of a sensor, the lead question could be, for example, when will the contamination exceed the error thresholds? And therefore we calculate for each channel, contamination channel, how long it will take until the front screen will not work anymore. Therefore, we have a kind of classification for it. So if the time is more than 1 month, we only say, okay, it's more than one month, all is fine. But if it's less than 30 days, then we show the exact date. And that we do with a probability of 95%. And therefore, we need to work very intelligent with the data. So it's an important topic how many historical data we use. In this case, 30 days, for example. We need to interpolate data gaps, for example, or reduce the data noise and outliers to get a really good value as a calculation. And at the end, of course, to apply the correct prediction model. For example, if we talk about the device temperature, it's a complete another prediction model. So there we only take a focus in the future about several hours or 1 or 2 days in maximum, and so there we need a complete another model. But beside the health status, there's a lot of more. So there is, for example, the topic, the task of the device itself. And if we talk again about LiDAR sensors for cranes, RTG cranes, STS, or also for HEVs, then we talk about the mentioned red and yellow fields, the field status. And of course, we can also monitor the field status and say, okay, is it free or is it not free? We can also do some calculation on it and say, okay, how many infringements there was in the last week, in the last month, how was the duration of it, and so on. And if we talk about a mobile application, we can also add additional information, like the positioning of an HEV, for example. And with this information, you get a lot of important knowledge about your application, like, for example, in each corner, in corner number 7, for example, you have every time the same problem. And then, of course, you can optimize your application. You can also get all of their performance indicators. So you can calculate for a crane or HEV, for example, how was the downtime based on the field infringements and compare the applications to each other. So you see, for example, crane number B has 20% more downtime than the other cranes. And so you can do a lot of improvements with this knowledge. Now I want to share with you a short video. In the video, you will see the products, monitoring box and prediction box, and how the products work. Coming back now to a success story, coming to our customer MSC Terminal Valencia. MSC Terminal Valencia is using also the shown products, and now we want to share the success story with this customer with you. MSC Terminal Valencia is one of the largest container shipping lines in the world, with an important logistic hub for MSC and the annual turnover of over 1.5 million TEU. We have a customer interview, now an extract of this customer interview from our Spanish colleague Enric Puyol and from Xavier Campos. He is senior maintenance engineer for MSC Terminal Valencia. They talk about several topics about a common project, and we have now 3 parts of it. They talk about the environmental challenges, they talk about the situation in the past, so they did in the past preventive maintenance, and they talk about the solution and benefits of the current solution.
There is a lot of contamination also from the ships and also from the city, and there is a lot of sand and salt, and we are also have problem where is a lot of rain, because there is a lot of harsh in the sensor. And in our planning in maintenance in the past was clean this sensor every 8 weeks, and it costs around 8 or 12 hours per crane. So at the end, it's a lot of work to do. When SICK offer us this solution, we understand that it's a good way to reduce the crane maintenance. For us, I think is the best solution, because you can also programming through the SOPAS system this contamination alarm, but it's really nice to have in a nice dashboard, and can see all this data in real time.
Please let us understand more about these benefits that you see with the new system after this more than 1 year that you have it running on your installation.
Yeah, Enric, with the SICK solution, it's a real plug and play, because you only need to know the IP of every laser sensor or device you want to monitoring, and you put in the same network, and it's really easy to put in operation. And the results, it's immediately, because we come from an scheduling maintenance based only in the time, and we don't have the knowing of the real condition of the laser. Now it's an efficient condition-based maintenance, because it's more efficient. So you have the live data in your dashboard, and have the maintenance prediction, because SICK developed a system to try to have the prediction of the next action to cleaning or replace the laser or whatever. And you now do the maintenance in the right time, not wherever you are scheduled. So for us, it's an optimization of the maintenance work, and you can also configure the alarm message to receive when the status of one of the laser change. And for us, it's an economical reduction of the maintenance cost. So we can also reduce the downtime, and also we reduce the total maintenance hour of these cranes.
Okay, coming now to the end of this presentation, and therefore I want to add some figures again to this success story. So if we talk, for example, about 3 cranes, there are for 1 year cost savings of roughly 150 hours. If you think about a whole port, then there are cost savings or labor cost savings of 4,000 hours per year. And if we think about, okay, what are the costs in Western Europe for a service technician, then you can save roughly €500,000. And there we don't talk about the reduction of the downtime of the cranes itself. If you want to read more about the success story, you will find also a sensor block article on SICK.com. Now to summarize the important points, we can do condition monitoring and predictive maintenance to monitor and predict the health status of the devices itself. So there you can optimize the maintenance time and of course also the resources. You can prevent unplanned downtimes, and then at the end, of course, increase the availability of the sensors and also of the port facilities too. If you think about the task of the devices, then you get much more transparent insights into your processes. So you see, for example, that one application has a downtime 20% more than another one. You can optimize with this information then the performance of it, and in the end, of course, you can shorten your ship idle times too. With these words, I want to end up the presentation. If you have any questions, please let us know it or contact us. And I want to hand over back to Ramona again. Thanks.
Thank you very much. This was a great example on how to help our customers in their day-to-day life to decrease efforts, to decrease maintenance costs, and also increase availability of the machine. So really great example. Let's see what we have in the chat. Is it possible to retrofit existing machines with SICK's condition monitoring solution?
Yeah, that's possible. That's easily possible because we have there already a gateway. It's only a plug-and-play solution, so it's possible to use it on a brownfield application, so older applications, but it's also possible to use it for new applications, so greenfield ones. Both are easily possible.
Perfect. Very good if you can do both. Thank you very much.